The seventh question that we have is again an important question which came in IIT some time back. We need to find out the equation of the line passing through the line given by these two planes, that is the intersection of these two planes, and the line's perpendicular distance from 2, 1, -1 is given to be equal to 1 upon root 6. So we know that these two planes will intersect in a particular line. Let us find out the general equation of all the family of planes which are passing through the point of intersection of these two planes, that is a line which is given by P plus lambda q is equal to 0. Let us write this down. This is equal to x plus 2y plus z minus 2 plus lambda times 2x plus y minus z minus 3 is equal to 0. This is definitely an equation of a plane, because any equation of the form ax plus by plus cz is equal to d is an equation of a plane. Now this plane also passes through the point of intersection, that is the line of intersection of these two planes, because any point lying on the line of intersection of these two planes will make both these quantities equal to 0, and therefore it will also lie on this plane. Therefore this plane is a general plane, or rather family of planes passing through the line of intersection of these two planes P and Q, which are given to us over here. So in solving this we get 1 plus 2 lambda times x plus 2 plus lambda times y plus 1 minus lambda times z minus 2 minus 3 lambda is equal to 0. Now the perpendicular distance of this plane from this point is given to be 1 upon root 6. Therefore we can write, we already know the formula for the perpendicular distance of a point from a particular plane. We first put the point over here to get 1 plus 2 lambda into 2 plus 2 plus lambda times 1 plus 1 minus lambda times z, that is minus 1 minus of 2 minus 3 lambda upon root over 1 plus 2 lambda whole square plus coefficient of y, that is 2 plus lambda whole square plus 1 minus lambda whole square, and this is given to be equal to 1 upon root 6. On solving this we get 1 plus 3 lambda upon root over 6 times 1 plus lambda square is equal to 1 upon root 6. We can cancel root 6 from both sides to get 1 plus 3 lambda whole square is equal to 1 plus lambda square. Therefore on solving this we will get 1 plus 9 lambda square plus 6 lambda is equal to 1 plus lambda square. Therefore we get 8 lambda square plus 5 lambda is equal to 0, that is lambda is equal to 0 or lambda is equal to minus 5 by 8. Now we get two values of lambda over here, 0 and minus 5 by 8. The value of lambda is equal to 0 is rejected because we had written the equation of the plane to be equal to P plus lambda q. If lambda is equal to 0, then the plane will get as P itself. Therefore we are not getting any new plane. Therefore the value of lambda selected will be equal to minus 5 by 8. On putting this value of lambda in the equation that we had already got, the equation that we already had, 1 plus 2 lambda x plus 2 plus lambda times y plus 1 minus lambda times z minus of 2 plus 3 lambda is equal to 0. On putting the value of lambda is equal to minus 5 by 8 over here, we get 2x minus 11y minus 13z plus 1 equal to 0. And this is the final equation of the plane that we wanted.